There's different types of acidification. The big one that a lot of us are focused on is ocean acidification, and that is this long-term signal that is the ocean sucking up the CO2 that we put into the atmosphere by burning fossil fuels. There's also coastal acidification.
Coastal acidification is a process whereby a lot of local factors and biological processes that occur from that can create low pH in the bottom waters of our coastal system.
In the Mid-Atlantic alone, there are over 40,000 jobs that depend on ocean resources. And that accounts for over $1 trillion in personal income. So it's really important that scientists and engineers and folks in the fisheries industry all work together to better understand acidification.
A glider is basically a robot that we can put in the ocean, and it collects data for scientists to understand what's happening in the ocean.
We've been deploying gliders fitted with pH sensors off the coast of New Jersey since 2018. So we're able to look at the annual cycle of pH throughout the year. And we can see that in the summertime off the coast of New Jersey, in the bottom water, we see low pH levels. The advantage of using gliders is that they're collecting high resolution data. So that means they're collecting a lot of data over space, horizontally, but also vertically. They're diving through the water column, so we're collecting data from the surface to the bottom. And then the gliders can stay out for 3 to 4 weeks, or they can stay out for a year. The data that we're gathering now is really good for, people like water quality managers or the State Department of Environmental Protection.
We fly our gliders right through where the sea scallops are living and breeding, and we can use that data to identify hotspots where ocean acidification might impact sea scallops and the fishery itself.
On a state level, resource managers and local decision makers can help by improving protections around our coastal zone.
New York is increasing our monitoring. We are doing a lot of work to reduce inputs that could potentially harm ocean and coastal health.
So that can look like creating nature preserves, or it can look like natural habitat restoration, so increasing the number of oyster reefs in coastal waters, or seagrass restoration projects.
Seagrasses can actually improve the conditions locally that are detrimental under ocean acidification. So when they're photosynthesizing, they're taking carbon dioxide out of the water. And so that's basically the opposite of ocean acidification.
There's probably a good 10 to 15 startups in the US that are based around some type of carbon removal in the ocean. For us, we would like to use the ocean as a natural sponge to remove carbon dioxide from the atmosphere. So we can affect chemical changes in the ocean by adding sources of alkalinity. So if we remove acid from seawater, we are raising the pH. This is directly combating acidification in the ocean, and it's done in a way that allows CO2 from the atmosphere to be sucked up into the ocean.
Vesta's approach to removing carbon dioxide from the atmosphere is to take a naturally occurring mineral, which is called olivine, and then spread it onto beaches and other coastal environments in order to remove carbon dioxide. It works by, when it dissolves, it absorbs carbon dioxide and converts it into a safe and stable form of bicarbonate, as like baking soda. It's the very same chemical. And that is hopefully a form that the ocean can hold on to for hundreds, if not thousands of years. This is definitely only part of the solution. I think we've all figured out that no one single carbon removal strategy will be enough. So we need many of these carbon removal strategies, and then we still need humans to reduce the emissions of carbon dioxide as well.
Technological advances in the field of marine carbon dioxide removal, along with reducing carbon dioxide that goes into the environment and nutrients that go into the environment, is all part of a solution to help reduce acidification. One can't solve all of the problem, but all three together can help us get the ocean back on track.